Hey, what's up everybody? It's Lando and today I'm going to be teaching you how to get started with Python. What I want to do is I want to create a series of videos that takes people from not knowing any type of code at all to being proficient Python developers, meaning that you can create your own projects, or if there's something that you want to be able to complete, all you have to do is load up the docs and you'll be able to do that. Instead of installing Python, we're going to use a website. We're going to use Replit. And Replit allows us to use Python code without even having to install it. So the link is in the description. What I want you to do is I want you to click on that link and I want you to go to Replit and you're going to have to create an account. Once you create an account, it's going to send you a verification to your email. I believe you just click that verification, and once you do that, it's pretty set. I will have a description on how to do that below, but just in case, it's not too difficult. It's easy to get started. So you may be wondering, why Python? Python, in my opinion, has one of the lowest barriers of entry when it comes to actual programming languages. It's simple to understand and it's intuitive, and that's what I really love about Python. It's just you can look at a Python code and you can kind of figure out what's going on. With Java, it's not the same. You'll have like public main and then public void, and it's a bunch of additional text there that makes it seem more complicated than what programming actually is. Programming is difficult. I'm not going to say that it's not, but it's not impossible. If I can learn it, then you can learn it as well. So Python has a low barrier of entry, and that's what I really love about it. It's an intuitive syntax, and syntax is just another way to say language. Syntax is something that means that the computer reads that and it understands what to do based off of your syntax, based off how you place that. And then it's also a powerful language. If you're looking to automate your processes, if you're looking to analyze data, if you're looking to scrape websites, which means go to websites and pull information from the website onto your server, it's a very powerful language. You can even create graphic user interfaces. You can create standalone applications. You can create websites with Python. Python is a very strong language, and I think that it's one of the best languages to start with, which is why I'm going to go ahead and do this for you. Okay, so let's get started. By now, you should have an account created with Replit, and if you don't, then once again, go to the description right there and just create that really quick. But for those who do have the account created, let's go ahead and get started. All right, so right here is the home page for Replit.com, and I'm not really teaching you how to use Replit. It's more so about how to use Python. So what we'll do is we'll just go ahead and get started. We'll go over here to the top left underneath your username, hit create. And what it's going to do is it's going to start loading to create a REPL. So it's going to ask you which template to use. And your template is basically just what language do you want to use. What you can do is just type in Python. And the great thing about Replit is Python comes pre-installed. You don't have to install or import anything. Go to the official languages and you'll see Python right here just by itself. Click that. It's going to automatically generate a title for you, but you can use whatever title you want. So let's go ahead and create REPL, and then it'll launch it up for you. It'll get it loaded. All of that good stuff for you. One quick thing about REPL is it is a free software, so sometimes it does run a little bit slow. If you try to run your program and it seems like it's frozen, all you have to do is just refresh your page and it'll launch your kernel back up. So here we are, we have the home page for your REPL, and let me just go ahead and talk about the important parts of this, things that you need to know. At the top, you can see this green button. This green button means run, and that means run your program, run your script. It's going to take what's inside of here, and it's going to throw it into your console. This is your console. A console is basically like a piece of paper that the computer uses to print off or output text or output information. It's like a notebook. If you're writing with a notebook and you have a pen you're writing with, the piece of paper for you is your console. The console for the computer is this right here. This is the output screen. This is where it's going to display text, okay? Over here on the far left, we have our files. We have main.py. Every Python program it will have a .py extension. For you newbies and people who are learning Python, please remember, if you're going to save a Python script, save it as .py, okay? And I'll go ahead and introduce a README as well, because as you continue to learn Python, READMEs will become important. So READMEs just basically tell you how to get started. That's all it is. It's an instruction for your program. It's an instruction for your package. This right here is telling you how to get started with Python on Replit. We don't need that because I'm going to be driving this for you. So let's go back to main.py. All right, so Now what I'm going to do is I'm going to switch to a different REPL because I already have, instructions loaded up. Okay, so I already had some instructions written out just to make it a little quicker for everyone and make it easier for you to understand and follow along. At some point, we're going to start writing code, and whenever we start writing code, I'll let you know when I'd like you to follow on. But honestly, I think that the best way for you to take in this information is to watch this video the first time without typing anything and then come back a second time and start filling it in. However, you can also follow along as I type as well. It's whatever your preference is. So before we get into any real coding, I have to explain this to you right here. So this first line right here on line 1, this is marked out code. You can signify marked out code with a hashtag. And what that does is it signifies to the computer that it does not need to interpret that code. It does not need to put it onto the console. It does not need to think that it's a function. That part right there is simply for human readers. Only people who are reading your program can see this, and they have to have the actual script. If you create a package and you send an application to someone, the hashed out or the hash, I can't speak, but the hashtag will not be interpreted, okay? So it's important to know that the purpose of this is just to send and leave notes to further explain your program. Okay, so now you see this right here. This right here is a doc string, and a doc string is very similar to a marked out code. However, the computer can still read this. The computer can still read this. So in this instance, if I ran my program, it wouldn't do anything with either of these two. However, if I put my doc string in a print statement, and I'll show you a print statement later, if I put my doc string in a print statement, then it will print that doc string. So it will interpret your doc string as text, as a string. However, unless you format it, it will not bring it as code. Okay, so I bring that up because throughout this tutorial, you're going to see green and orange text, and I just want you to understand what that is, okay? So now let's go to our key terms. So we already kind of talked about a console, and the console is where the outputs are displayed. Right here is your console. So whenever we run a program and we print something, this is where it's going to pop off at. Our output is what is displayed in the console. It's our text. So our output is basically the contents of our print statement. Syntax, once again, syntax is the language that tells the computer to do something. It's the way that you communicate with the computer, you know what I'm saying? So let's say that I wanted the console to say hello world. I couldn't just type hello world into my script. It would throw an error depending on how I did it. I would have to use the syntax print to let the computer know that, okay, this user wants to output something onto their console. So that's basically what syntax is. Syntax is the way that you communicate with the program to make it do what you want it to do. And we've already talked about print. It's a function that populates the console with data, and return. Return is something that you may not understand fully until you start using it, but what it does is it assigns a value to a certain reference in a certain location, okay? So with that being said, let's go on to our data types. Our data types, so the first thing is an object, and the object is so important when it comes to Python. Python is considered an object-oriented programming language, OOP. And what that means is the basis of Python is just throwing objects left and right, moving objects through a pipeline, dissecting objects, and seeing what contents are in there. You can think of an object as a box, and a box contains like a label on the outside to let you know what that box is, and then within that box it has different type of instructions on how to interact with that box. That's what an object is, okay? So you can just think of everything as an object in Python, and that's why I put all of these data types beneath objects. So the first one that you have is a string. A string is simply a text, A through Z. It's simply a text. It's something that is also within a doc string. If you have anything within a quotation, it doesn't matter if it's a number or if it's a plus sign, it's going to be interpreted as a string. You can think of strings as synonymous with text. Integers, they're just numbers. They do not have quotations surrounding them. 0 through 9, and you can create whatever type of number you want with it. You can also use negatives. You can also use periods, and that's called a float. We won't talk about floats in this video, but an integer is simply a number, okay? A variable is something that gets assigned a value. You can look at it closer to an object. So let's say that, and we'll show variables later, but a variable is just something that gets passed a value as a reference, and you can access that value by referencing that variable. That might be confusing, but I promise it's very simple, and I'll show you in a bit. Okay, so Booleans are nothing but true, false statements. And let me go ahead and add that onto here. True or false. Both of these two right here are Boolean statements. So if it's true or false, that's a Boolean statement. It's as simple as that. All it does is evaluate whether a condition is true or false. Nothing more difficult than that. And then none. None just means that there's nothing there. It's null, it's void. So let's say that you have a box and there's nothing in that box. Then technically the box is not none, even though it's empty. But if you don't have a box, then in terms of box is equal to none because it doesn't exist, right? So anytime that you have a variable and you need to just have it like a placeholder that you might use later, assign it to none, okay? And that might seem a little complicated for right now, but I promise you all of these concepts are very, very simple and you'll understand it really quick. So here's some quick examples of a string, text, and Boolean of such a nature. Strings right here, this is a text. It is not intended to tell the computer to do anything. Anything within a single quote or a double quote is considered to be a string. Also, a doc string is a string as well, and that's what we showed earlier with the triple quotations, right? So that's a string right here. Here's an integer, and you can use any type of number combination for an integer. Right here, that's a valid integer, that's a valid integer. Very simple. Once again, a Boolean is true or false. And here's an example. Is it nighttime where I'm at? Boolean would equate to false. Is it daytime where I'm at? Boolean would equate to true. It's simple as that. And once again, null is none, and the syntax is just none. When you're using a Boolean or when you're using none, you have to use them as titles. So for here, it needs to be a capital N. True needs to start with a capital T. False needs to start with a capital F, okay? All right, so now let's talk about variable assignments. And we already kind of talked about what a variable is. Now, a variable assignment is how you fill that variable with a value. It's how you pass a reference to that variable. And the syntax for that is with an equal sign, okay? So let's see an example right here. Some variable, and you can name this whatever you want it to, right? If I just wanted to name it variable, this will be valid as well. The only thing you need to be careful of is not using the same language that Python has. Python comes with some predefined variables. Just don't use those. But outside of that, you can call your variable whatever you want. So right there, that's a valid variable, and we can say that it is equal to test. So whenever we try to access variable, or if we changed it back to some variable, whenever we try to access this, what would be passed is this text, this string right there, test, okay? Very simple. And you see right here, this is a double equal sign, and what this means is equal to. Okay, and we'll get to that later. And what that does is it returns a Boolean, true or false. It's a way to evaluate a conditional, and we'll talk about that more in depth later. Okay, now here is your print statement, all right? And the print statement is how we output information onto our computer, and this is where we're going to finally write some code. If you decided to follow along and code with me during this first run, then this is where you'll start typing as well. So anytime that you learn a new language, or anytime that you create something that has the power of outputting something, the first thing that you do is make it say hello world. That's the first thing that you do. So let's see what happens when we click run. Another way to run your program, if you're on the Mac, is to press Command and Enter. I'm not quite sure what it is for Windows, but you'll see me just using short keys to make it print or make it operate. That's just because I'm using a short key, but anytime that I'm running a program, you can also just hit run. So real quick, while this is loading up, I want to demonstrate that Replit sometimes takes a little bit of time to load. That's because it has a kernel that's taking the information from your program, and if it realizes that you haven't ran it in a while, it might put it to sleep and it's just waking it back up. If it takes a long time for your kernel to wake back up, just refresh your Replit, it auto saves and everything will still be there. Okay, so we ran our program. Let's just run it again in case you missed that. We ran our program and here we are. On our console, it says, hello world. Type that for me. Once you type that, then you have written your first code, legit. You have written your first script. You have written your first Python code. So if anyone asks you, do you have any experience with Python? Have you ever programmed before? Have you ever coded before? The answer is now yes. It's really that simple. That's why I love Python. In other languages, it's a lot more complicated just to get your console to say hello world, but in Python it's as simple as that. So I want you to recognize that we put hello world in quotations because we need to pass a string anytime that we're printing something, or we need to pass an integer. A print statement can be very complex, but if you're just wanting to print a text, then you have to make sure you pass the variable or you pass it as a string. So let's go ahead and do an example of, some calculations, right? So let's say that we wanted to print 2 plus 2, right? And that's going to equal 4. The print statement is powerful. It can perform calculations inside of it as well. So hit Command Enter or hit Run, and there you are. There you have it. You have 4 outputted on your screen. So now let's do some variable assignments, right? Let's do some variable assignments and let's print those out. So I'm going to use my cats as an example. I have 2 cats. One is Pepper and one is Peach. So let's go with first cat name. Okay, that is my variable right there. Whenever you're creating a variable, it's important to know that you cannot use spaces. So if I try to do this and assign it as something, what it would do is it will consider these as 2 separate entities. However, there's no comma there. You have to have a comma to separate entities. So if you're going to use it, best practice is to use underscores, right? Underscores. If there's going to be multiple words in your variable, use underscores, and that's your best practice for variables. So his name is Pepper. Okay, so now let's demonstrate the print statement with a variable, okay? Print, and now we don't need quotation marks because we have a variable. We have a valid variable. So there we have it. Let's go ahead and run our program. Print first cat name is going to output Pepper. We could also just do the same thing. Once again, a print statement will print anything that is valid. If it has a valid print along with it, you can print it. So you can print a string, you can print summaries, or you can print, or not summaries or calculations, you can print text. But what we're gonna do is we're gonna focus here on passing a variable, because I want to demonstrate that this variable right here does nothing but take this content right here and stores it here. It takes Pepper and it stores it here. So anytime that you try to print this, what Python does is it looks at this variable and it sees what the content is and it passes it through there. There we have it, okay? So now let's go ahead and also put his age in there. So first cat age is equal to 4. You can also pass integers. You can also pass integers through variable, and this is going along with the object-oriented programming. Any type of valid object can be passed into a variable, so that's classes, functions, integers, strings, things of different nature. Anything can be passed through there. So let's go ahead and print that, and that's going to print 4. It's going to print the same thing, right? Okay, so now let's go ahead and use some text with our print statement. So what I want to do is I want to print my first cat name is, and then say Pepper. So we can say print my first cat's name is, and then we got to put a space there because we want to separate them. And once again, remember, if you're going to use more than one variable or more than one entity, you got to put a comma there. And then we can say Pepper. So what that's going to do is, oops, pardon me, I'm sorry, first cat name. So what that's going to do is it's going to print my first cat name is Pepper. And there you have it. My first cat name is Pepper. But what I want to demonstrate to you is something that's going to definitely be a best practice for you. And I highly recommend that you learn how to do this right now, because it just makes the print statement so much easier if you're dealing with variables. So it's called a format string or an F string. And here it is right here. And with Python, it's really simple to use. You put in your print syntax, and within your parentheses, you start it off with an F. And that F indicates to the program that you're using a format string. And then you have to add your quotations as well. And when it comes to quotations, you can use double or single. And there's a best practice. And there's an argument about what to use, but in this instance, let's just keep it simple. So we'll say that my first cat's name is, and the way that you pass in a non-string is through curly brackets, okay? So you have to put curly brackets in there, and then you put your content. So we'll say first cat name, and what you'll see is it's going to print the same thing as here. It's going to have a duplicate basically. So let's go ahead and run that, and we'll see that, yeah, it did the same thing. My first cat name is Pepper. My first cat name is Pepper. So you may not see the value in using an F string currently, but I I promise you, I promise you, I've been through it. Go ahead and learn to use F strings because there's going to be times where you need to pass multiple variables. And this just looks more intuitive, right? This looks more intuitive than this right here. And that's one of the biggest strengths when it comes to Python, intuition and intuitiveness. And let's just go ahead and demonstrate why it's helpful. So let's say that we wanted to add his age. And I keep going over there to the sidebar. And his age is first cat age. You can use multiple variables. There we are. There we go, right? Beautiful, beautiful. Okay, so the next thing I want to talk about is input. So there are going to be times where you want the user to put in information and have it delivered to your program. Let's say that you're creating a social media site and you need your people to log in. Or let's say you're creating a survey and you need people to respond. Or let's say that you're creating a Wordle game or any type of game where you need a user input. Input is what you'd use for that. So the syntax is input in parentheses. Okay, so let's talk about my second cat, right? And we want this one to be constructed in a method where the user can put in their second cat's name. So we'll say second cat name equal, remember our input syntax is input with the parentheses. And the great thing about these IDEs is if you make a mistake, you can see this red part right there. If you mess up and you provide an improper syntax, the computer's going to let you know. It's going to raise a flag for you. So that's a great thing about these online IDEs. And even the ones you can download like VS Code, they're pretty great. So right there we have an input, but also we need to pass in some type of instructions, right? Because anytime that you're putting something into a website or a program, there's got to be some type of instructions. Unless you create the program, then you won't know what goes in there, right? It's like a label. It tells you to do this, provides instructions. So we'll say, what is your second cat's name? Okay? And what that will do is it will print an input. So it's going to print what is your second cat name, and it's going to give you the option to put in some text. So what we want to do is to demonstrate how it takes that in is let's print second cat name, okay? And before we do that, let's go ahead and discuss this one more time. So we're creating a variable and we're assigning it to an input. And what the input is asking you to do is provide the second cat's name. And what that does is it's going to take in the input and it's going to pass it as a value to second cat name. So whenever you print second cat name, it takes this, it looks for the address, it recognizes it's a variable, it looks for the value within that variable, and that variable is going to be whatever you assign to it. Okay, so let's check that out and see how that works. Okay, here we are. What is your second cat's name? Her name is Peach. She's pretty. She's a cute girl. Peach. And there we are. It prints second cat name. It's really that simple. It is really that simple, y'all. Python is a very, very strong program. Now, one thing to note is that for your input, everything that you put into there is going to be passed as a string. So let's do another example. Let's go second cat age. And she's young. She's less than 1 year old, but we'll say, how many months is she? Okay. How many months is she? And then we'll print second cat age. Now, when I print second cat age, you're going to think that it's passing it as an integer because it's going to look like an integer, but you'll see really quickly that it's not. So Peach, and she's 4 months. Okay, so there we are. And what I'm going to do is I'm going to mark this out because it's going to ask me to put that in there every time, and we don't want to do that. Okay, so we have that. So there's some numerous ways to prove this, but what I want to do is I want to show you by using the type function with Python that it's going to be a string and not an integer. And let's demonstrate what an integer should look like. Okay, so a type right here, this function right here is not something you need to learn. Once you get better with Python, it's going to be very helpful for debugging, but I'm just using this to demonstrate a point. Okay, so how many months is she? She's 4 months. And here we are. So what we're printing is the type for second cat age, and that's a class string because once again, your input is going to be a text. Anything that you pass through it is going to be considered to be a text. If you need it to be an integer, then you'll have to do an explicit conversion, and I'm not going to demonstrate how to do that here, but it's really simple. I'll show you how to do it in a later video, okay? So yeah, I think that's going to be a good explanation getting you started for input. So what we'll do is we'll highlight out these codes. We don't want to throw any errors. Okay, let's go to our operators. Operators are pretty simple. If you understand the basic math, I think high school math here, then it's super simple, y'all. You just gotta understand the syntax. So let's just use our print statements to test them out. So 2 plus 2, we can do it that way. Let's print 2 minus 10. Let's demonstrate a negative number. And let's say print 2 times 5. It's really simple. Print, I'm not going to demonstrate too much. I just want to give some examples, right? And then print 10 print 10 divided by 2, okay? Pretty simple stuff. And what it's going to do is it's going to perform all of our calculations. It's really that simple, and I want to demonstrate that you can also perform calculations through a variable. So let's say calculated variable equals 2 times 2, print this is our calculated variable. And then remember, you gotta pass it as a curly bracket. This is our calculated variable, calculated. Remember to add in your quotation marks, but I'm just gonna run it anyway because I wanna show you an error. Luckily I haven't caused any errors yet, but I want to demonstrate an error when you have a syntax problem. So right here, syntax error lets us know that your syntax is incorrect. End of line while scanning string literal. What that means is it's scanning your literal string, but there's nothing telling it when to stop scanning for that. That's because we don't have our closing quotation marks. So whenever you do that, you see the little red arrow went away. There's nothing yelling at us saying we have a problem. There we go. So once again, you can pass in calculations through a variable. It's really simple. It's really simple with Python. Everything is just so intuitive. I love it for that. I love that with Python, okay? So now let's go to our equality evaluators. We kind of talked about this earlier. So our equality evaluator is going to return a Boolean, and there's different ways that you can manage this. So here's our examples right here, and I think that I should go ahead and demonstrate it as a actual statement on the output as well. So let's say x is equal to 10 and y is equal to 50. So if we printed, oops, this is JavaScript, sorry. All right, so we printed x equals y. What this is asking is x equal to y? So without you even knowing any Python code, you tell me, is x equal to y? It's not, right? So what that's going to do is it's going to print false. There we have it, false. Okay, so let's say print x is greater than y. What do you think is going to be outputted? Correct, it's going to output false. So the next one is x is greater than or equal to y. And I want to spend a little bit more time here because this one might be a little confusing. So what this does is it's saying, Python is just so great. It's literal, right? It's saying x is greater than or equal to y. That's all that it's saying. And it's just like simple math. X is greater than or equal to y. In this instance, that's going to return false. However, if we turned x into 50, and that's going to obviously change some of these responses as well. But the third one is what we're looking for, and it's going to return true because x is now equal to or greater than y, right? And that's the power of that. Sometimes you want to see if two variables are the same or equal or less than each other, and that's how you can do that. So I'm not going to continue with the rest of them because they're just inversed, but the important part here is the double equal sign is an evaluator. It's evaluating conditions to see if they are the same. It's not to be confused with one equal sign. One equal sign means assign. Two equal sign means evaluate. All right. Then you have your greater than and your less than right there. Simple math. And then you also have your greater than equal to, and you could also just swap it like that. It's as simple as that. It's really that simple. Like I said, Python is a beautiful language, beautiful and powerful language. Okay, so the next topic is one of my favorite topics, data structures. And when I was learning Python, no one really emphasized the importance of data structures to me. And maybe that's because they wanted me to understand the syntax. Maybe they want beginners to just really understand how to get your program going a bit. But I think that it's important to let you know now, data structures are going to be the backbone. If not the backbone, it's going to be a significant part of your programming experience. It's going to be a significant part of your programming journey, because data structures are going to be the way that you can make your programs run efficiently. It's going to be the way that you can handle large data. And with Python, that's what Python is for. It's for handling large data. So data structure, I really implore that you take your time to learn them, okay? So the first data structure that we're going to talk about is list. And a list is basically a container. A list is basically a container that contains ordered objects. I like to think of a library for an example of a list. If you go to a bookshelf and just pick the top row, that is a list. Those books are placed there in a particular order. They may be ordered by author name, they may be ordered by book title, they may be ordered by ISBN, or there may be some other type of primary key that the library has set up. However, those books are in a particular order, and that is a list. That's all that a list is in Python. It is a container for ordered objects. That's as simple as it is. So let's go ahead and create an example of it, right? And we'll continue with our cats. We'll turn our cats into a list. We have two of them. Let's do that. So we can define it as a variable. And as you see above, the syntax is either with a closed and open square brackets or with a list in a parentheses. So we could say either cats are equal to this, and all of these are going to be valid ways of starting a cats list. Cats is equal to a list. And we could also just fill it in, right? We could also say cats equal to, we'll go with first cat name. You can pass any valid object into your list, and that'll work. Any valid object can be assigned into a list. Or we can say cats equal to list, and then first cat, oops, let me add my underscore, first cat name, Pete. And I feel like I feel like this IDE giving me the errors is what's helping me to like not make errors. I want to reassure you, y'all, that errors are okay. I made so many errors when I first started. I was using Jupyter Notebook. Just going on a quick tangent, I was using Jupyter Notebook, and Jupyter Notebook for me didn't alert me anytime I had syntax errors. So every time I ran my program, syntax error or I missed something. Now I'm using IDEs that tell you when you have an error. So that's why I'm not making mistakes, but I want you to know that mistakes are common. They're common for senior developers. They're common for beginning developers. It's okay. I'm just a little bit better than I used to be. Okay, back to the point. So all of these are valid ways to start a list, okay? We're going to go with this one right here, though. So cats is a valid object, which means that we can probably print. We can probably print it. So let's do that and see what it looks like when you print a list. So what that's going to do is it's going to return. Oh, it looks like my REPL, I was talking too long and my kernel went to sleep. No worries, I can go ahead and tell you what's going to happen. So it's going to return the reference value for the variable first name. And if we climb back up here, we know that we assigned the string pepper to first cat name. So what is going to happen is whenever you print that cat's list, it's going to look inside of that cat's list and it's going to take each object at a time and it's going to print, in this situation, it's going to print the reference. And since our kernel is back up loaded, we can see that. We print first cat name, there we are. What it did is it looked at the address for this object and then it took in the value and it returned it to your output screen. It's really that simple, it's beautiful, right? And as I said, you can pass any type of object, so that means you can pass in a text as well, and just to demonstrate, you can pass in a number, and this would make sense with our cat list, but still, just to demonstrate that any valid object can be passed into a list. There you have it, peach, pepper, peach, 4, okay? So once again, to reiterate, lists are ordered structures, okay? And the way that Python indexes and keeps track of order is starting at 0. It indexes items, it indexes objects, and your first item, your first object is 0. That might be something you have to get used to, but after some point using Python for so long, it just becomes second nature. So let's say that I wanted to access only the first item within my list. The way that you index things are with a square bracket. So we have our square brackets next to our list, and then we need to pass in the index. So when you pass in 0, what it does is, okay, it says that this is a list and we have indexed it by 0. So they're wanting the first item within our list. Here's our list, here's our first item. We're going to pass that reference through here. So what it's going to do is it's going to print Pepper. There we are. Pepper, my man, there he is. Now, if we wanted to access Peach, we just change our index to 1. And there we have Peach. Now, what would happen if you try to, like if you made a mistake and you try to access an item that's not in our list? Well, it's going to give us an error. It's going to say index error, list index out of range. And anytime you see that, what that means is you're passing a number through your list that is greater than the amount of items within your list, okay? So that's as simple as what that is. Lists are a very powerful thing. It's really what I used the most when I first started learning Python. And it's because it's powerful. It's a great way to keep things organized together. However, there are other type of data structures, and I want to make sure that you all are not intimidated by them because they are very powerful. And one of those is the dictionary. The dictionary, I could go on for days about a dictionary because a dictionary is so powerful. It's one of my favorite data structures. And, ironically, it's the one that I avoided when I first started learning Python. Like, I learned the basic syntax for it, and I could create a basic dictionary for you, but whenever I was creating my own programs and creating my own scripts, I never really used a dictionary. So I want to implore to you that dictionaries are very helpful, and don't be afraid of them. Get to know them, get to know them. The only way you're gonna learn is by challenging and struggling and failing. So try to use dictionaries, okay? So dictionaries, they're beneficial anytime that you need to search information or anytime that you have a varied amount of information, like different information that are associated in some way. That's what a dictionary is for. Now, the way that a dictionary is set up is it has a key and it has a value. The way that you find objects is by accessing the key. If you know the key, then you can find all of the values associated with it. So let's go back to our library example. Okay, so let's say that we were looking for the book, How to Win Friends and Influence People, okay? What we would do is we would go to the librarian or we go to the computer and we say, hey, I'm looking for How to Win Friends and Influence People. And what they would do is they would give us the key. And the key in this situation is the exact row and the exact location. And what you can do is you go to that section of the library, find that shelf, and it points you exactly to where that book is. And that's the benefit of a dictionary as opposed to a list. If I was looking for a book within my list, then I would need to know exactly like what order it's in to find it. And if not, then I had to go through each item within that list to find it. So that's the beautiful part of a dictionary. A dictionary is a great way to organize things. It really is. So let's go ahead and create some examples of a dictionary. And what we're going to do is we're going to create a fictionary family, okay? First, it's important to demonstrate how to start a dictionary. Oh, there we are again. So I got to stop doing that. You can do it like this. That's a valid way of starting it. You can do it like this, dict. That's a valid way of starting it. The most common ways of starting it, if you already know how you want it to look, would be to go ahead and just fill it in yourself. And I think dictionaries are I think they're constructed beautifully. As you can see, I'm really a fan of dictionaries. So here we are. We have our curly brackets, and best practice is to just go ahead and separate it. And then you got to add your key, okay? Your key needs to be a string. It needs to be a string. It doesn't pass variables as keys within Python. So we can say, let's go with our mom. And the way that you assign a value pair is with a colon. So we have our key, which is mom, and then we have our colon. Now we could just put in nothing. Like if we just knew that we wanted to have a mom in there, but we didn't want to put the name or any type of value to it, then we can just do that, right? Okay. So then let's have another example. And the way that you separate key value pairs within a dictionary is with a comma. Let's go ahead and add a dad. Dad, we don't want to put the name in there yet. We're going to fill that in later. And I'm using the single quotations and the double quotations just to let you know that they're interchangeable. You can use them interchangeably. It's up to you. All right. And now if we wanted to actually add any type of value to our keys, we'll say, let's go with daughter and let's name her Julia. Okay. And then let's go with son and let's name him Oscar. All right. And there you have it. You have a valid You have a valid dictionary. Even though you have some missing value pairs for mom and dad, you still have a valid dictionary and you can print this. Print family. Our kernel might be asleep, but let's see. Let's see how long that takes. Oh, beautiful, beautiful, beautiful. And there you have it. There you have your dictionary. You have your mom key. There's your colon indicating a value, and that's currently empty. Same thing for dad. Daughter is filled with Julia. Son is filled with Oscar. Okay, so you may be asking, Orlando, then how do I fill in those values? The way that you do that is you first indicate what dictionary you want, and then you have to use your square brackets. Remember, if you're indexing, you got to use your square brackets, whether you're indexing with numbers, with key values or key pairs. So we'll go with mom first, and it is case sensitive. You have to have it inserted the exact way that is placed in there. And let's name her, let's go ahead and name her Stephanie, right? We'll name her Stephanie. Okay, now mom is filled. Let's go ahead and name dad, okay? Let's say that dad is going to be Tony. Family, dad is equal to Tony. And now we have a full family. So whenever we print this now, I made a mistake. Can you tell me where my mistake is before I fix it? Where's my mistake? Okay, let's go ahead and fix it. Let's go ahead and close our bracket. And that's the great thing about these IDEs. I'm telling you, they let you know when you make mistakes. So let's close this bracket, right? And then we have an additional bracket right there. And now we have a valid family. So whenever we print, we're going to see that these two value pairs are going to be filled. So let's run that. And now we have a full family. And the great thing about a dictionary is you can pass in any type of valid object as a value pair. So you can even add a list, or you can add an object or a class or a function or another dictionary. It's called nested. Nested is like a dictionary within a dictionary, or a list within a list, a dream within a dream, inception. It's just like that. So let's go ahead and give them some pets, okay? So family, pets. We could say is equal to cats. Now remember, cats is a list, and I'll demonstrate, different ways of doing it, but let's just go up there to verify that we still have cats created as a list. Where are we at with that? It's got to be right here with the data structures, right? Yep, cats equal first cat name Peach. Okay, so now we have family, pets, and then we're passing a list. So what you're going to see is it's going to add your pets here, and then the value pair for your pets is going to be a list. It's beautiful. Like that's art for me, yo. That is art for me. And whenever you really get into Python, you'll feel the same way. So there we have it. We have passed the list as a value for a dictionary. Dictionaries are very, very important and very powerful, and I might create a video about dictionaries themselves later. Tuples. So tuples are very similar to a list, except for the fact that they cannot be changed. So anytime you're using a tuple, you're just indicating to whoever's reading your program that this list is going to stay the same, it's not going to change. So let's say that we wanted to create a cat's tuple, right? Cat's tuple. And the way that you started off with is with parentheses, and we're going to have to pause because my cat is eating right now, and that's loud. Okay, so my cat is done eating. She's still kind of walking around. If she comes close, I'll pick her up and let you see her. But let's continue talking about tuples. So once again, tuples are used for anytime that you don't want to change it. Anytime you have information that's ordered but you're not going to change it, you do it like that. You can start a tuple with a parentheses, or just go ahead and fill it in, and I don't use tuples often. I don't think you will. I mean, I've been using Python for a while and I still don't use it often. So let's just keep this simple. Cats equals to pepper, and we'll just pass it as a string this time. We'll just pass it as a string. You could also pass it as a variable too. It's like with any other data structure, you can pass in a valid object and it'll work. Cats tuple. So whenever we print this, we'll see the same thing here up there. Okay, cool. There we are. That's cats tuples. Okay. So now we're going to talk about conditionals. Conditionals are very important as well. It's in my opinion, it's what provides that structure to your program. Your data structures do a lot of the heavy lifting. A lot of the heavy lifting is done with your data structure, but your conditionals, they direct your program. Like, hey, if this condition exists, or if this condition is true, then go this way. Else, if this condition is true, then go this way. It's a great way to direct your program and direct your system. So let's go ahead and talk about conditionals. A conditional is basically a triage of if, else, and else. And what that means is, if this conditional is true, then you can have the program do whatever you want to do. Your syntax is basically if, and then insert your conditional, and then have it with a close it with a colon. And the purpose is just to check if a conditional is true. The second layer is an else if, and the syntax is ELIF. It's concatenated. Else if can't speak. Concatenated into else if conditional. All right, and you got to add the colon right there. And what that does is, if your if statement is not true, if your if statement is not true, then it evaluates your else if statement, and you can have as many else if statements as you want. You can have as many as you want. You can have 0 up to as many as Python will let you. I haven't ever ran into a situation where I had too many, so I don't know what the limit is. And then what your else is like a finally, you know, it's like this is the last thing. If none of your if statements are true, and if none of your else if conditionals are true, then just do this, right? So basically, let's go ahead and give an example for like my day. It's currently 3 p.m. So a quick program will be, if it's 1 p.m., raise your hand. Like Simon says, I didn't raise my hand because Simon didn't say so. All right. And then the next one would be, else if 2 p.m., raise your hand. Well, it's not 2 p.m., so I don't raise my hand. And then else, you don't add a conditional. It just says else. If it says if everything above you was false, then just do this. So we would say else, raise hand. Now, here we are. I raised my hand because my if conditional was false. My else if conditional was false. And then my else just told me what to do if everything above me was false. So let's go ahead and use our dictionary to write some code and utilize this. So we would say if mom and family. That is an if statement right here. And then let's go ahead and say print, oops, whoa. And that's one of the problems with your IDEs, and they try to be super helpful, but sometimes you don't want them to be as helpful as they are. So print of mom name is family, mom, don't forget your ending quotations. All right, so what this does is it says, I'm sorry, I'm thrown off by this. Maybe my IDE is taking some time to generate. I don't think this is an error. Curly brackets, family, yeah. Oh, perfect, I love it. I see the error. So take some time, look at this, and think about the quotation marks. Can you see why there's an error here? And I'll go quickly through that because I haven't talked about why there's an error. So there's an error here because you have your opening quotation right here, right? So when you saw in our previous error, it was saying that it looks for an end of line string literal. So it's looking for a closing quotation mark. Well, our single quotation is not a closing quotation because it's not the same type. This is a double and this is a single. So we scan our literal, and that includes our variable, and we get here and we see a closing quotation mark. So the program is thinking that all of this is what you want to print. However, that's not the case because it's leaving this out, and that would just throw a bunch of invalid syntax errors because we don't have a closing curly bracket and we don't have a closing square bracket. So the way to fix that would be to use your single quotations. Undefined name mom, that's because it's a string literal, and there you have it. Your error has gone away, okay? So that's important for you to recognize. So let's go ahead and run that. If mom and family, that's how you run an if statement. If, and here's your conditional right here, mom and family. And when I was learning this, what they did is they put the conditional in a parentheses. That's not necessarily how you have to do it, but it is helpful to help you understand. So if condition, here's your condition, mom and family. Let's go to our family. Is mom there? Yeah. Family, mom equals Stephanie. So it's true. So what it's going to do is it's going to print mom's name is, and it's going to print her name. Mom's name is Stephanie. Okay, cool. So let's do another example. If dad and family, print if dad's name is family. Oops, I forgot my curly family. Let's remember single family. And the last one, I think we got it with no errors. Yes, we did. All right, so what would happen if you asked for a conditional that was false? So in these instances, everything has been true so far. Our conditionals have been true. What if we have a false conditional? So let's say if, I gotta stop throwing it to the left. Let's throw it to the right. If, oh, sheesh, if, and just to reiterate, you don't need the parentheses. If cousin in family, then print if cousin's name is family, family, cousin, add our ending quotation marks, and delete that extra one right there. Okay, so what do you think will happen here? Remember my time example earlier, raising my hand. What happened when my conditional was false? What did I do? Nothing, correct. So nothing's going to happen here. You're going to see that when this auto or when this regenerates, these two lines will be your last lines because our program realizes that there is no cousin, right? There is no cousin. So it doesn't do anything. It evaluates this and it doesn't pay attention to this if this condition is not true. It just skips it. Okay. So what you can probably see so far is that we've just used three if statements and we're kind of not utilizing it in an efficient way, in a pretty way. Anytime that you're writing code, if it doesn't look like, if it doesn't look aesthetic, then for me, I always question what's going on because that's how beautiful of a language Python is. And three if statements, it just isn't aesthetic. And another thing is sometimes if you have if multiple if conditionals, you're going to evaluate things that you don't want to evaluate. So let's say in this instance that we only wanted to find one family member, right? We just wanted to make sure that our dictionary was valid. So we wanted to print mom's name if mom was in there, and if mom's name is in there, we don't want to print that. Well, the problem is we have three if conditionals and they're going to be evaluated irrespective of each other, right? They're not linked. They're not linked. And that's the great thing about an if else statement. They're linked, they're connected. So if, let's go with another one. So let's stick with this one. We'll just stick with this one. So if cousin and family, print cousin's name is that, okay? So then the next one would be else if, and then you have to put your conditional, say else if, and let's say that the cousin's name is Omar. Let's say else if Omar and family, print if cousin's name is family, Omar, dum, 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 right? So what this would do is it would evaluate this. If cousin and family, print this. If this was true, then it would not evaluate your else if. But in our situation, it's not, it's false. So then what it does is it now evaluates your else if statement. Is Omar in family? Well, he's not. He's not. We have mom, dad, daughter, son. Mom, dad, pets. It's evaluating our keys, and Omar is not a key in our family, so it's not going to do this. So then what we want to do is we want to throw an else. And an else just basically says that, all right, well, if none of that is true, then just do this, just do this. So in our situation, if none of those are true, then obviously we have not added Omar, we have not added our cousin to our family, so then add your cousin to your family. And what you would say is family, and you tell me, how would you add a family member to a dictionary? I think I've given you the tools to be able to do that. Maybe you can pause and scroll up and figure out how to do that. If not, I'll show you right now. All right, so family, cousin is equal to Omar. There we are. So now we have added Omar to our family, and then we can print family, and what you'll see is it's going to, we'll leave this in. It's going to print mom's name, then it's going to print dad's name. It's not going to print cousin name is this, it's not going to print cousin name is this, but it will finally add the cousin on there, and then whenever we print our family, we'll see the cousin added. So let's go ahead and run that. Here we are. Let's make sure that we're accurate. And I mean, my mouse is already on it. Cousin right here. There we are. So that's what a conditional is. A conditional looks at your program and it allows you to create or control the structure. It allows you to create where information is passing, where functions are actually operating. And I think that, like I said, it's one of the most important parts of the architecture. Data structures are a great way to handle the efficiency and the load of your data, but conditionals are a great way to like design where it goes and what happens if this is triggered. So just one more time before I continue, these right here, if statements, if they're left alone, they will always be evaluated. So these two will be evaluated. But here we have an if, else if, and else. This if statement is evaluated if it was true, then else if and else would not be evaluated. The else if is evaluated since if is true, and if this was true, then the else would not occur. But since this is false as well, it just tells us that, okay, just do this. Okay, simple, right? You'll get a lot more practice with if, else, if statements. All right, so now one of the last things, or the last thing I want to talk about is loops, and this is like the motor for me. This is like the motor in Python. Loops. Your loops, oh, it's beautiful. Your loops are what allow the automation to be automated. It just continues, it continues, it continues, it continues, it continues. So let's talk about key terms for loops before we continue any further. So we have iterable, iteration, and range. So what an iterable is something that can be looped over because it has multiple instances of it. If you think of a 32 pack of water, each water bottle is an instance of that. Each water bottle is one instance of that. If it's a 32 pack, then you have 32 possible iterations of that. And what an iteration is basically pulling one of those water bottles out. You can replace it or you can remove it. So let's say I pulled out a water bottle and I drank it. Now I have 31 water bottles left. I have 31 iterations left in my iterable. An iterable is just something that can be unpacked and it can be used until you empty it. Let's go to our cats, right? A list is an iterable. A list is an iterable because it has multiple objects inside of it. If we wanted to iterate over our list of cats, what it would do is it would first grab the first, which is Pepper, and then it would grab Peach. That's what an iterable and an iteration is. Now, a range is as, you should understand what a range is. And if you don't, it's okay. A range is basically saying, hey, do this to a certain amount. I like to think of time in terms of a range. We have 24 hours, right? There's 24 hours in a day. So if we're looking at our day as a range, we would say that each hour is another hour getting closer to 24. And once you get to 24, you have met that range and now you are outside of that range. That's simply what a range is, okay? So there's two different types of loops in Python. You have a for loop and you have a while loop. A for loop iterates over an iterable, right? So once again, for time in hours, it'll be 1 hour, 2 hour, 3 hour, up to 24 hours, okay? Now, a while loop is an iteration in a range, in an iterable. So you would say while hour is within range of time. And we're going to give examples of that. It may seem a little bit complex, but loops are very, very simple. And I might create another series or another videos on loops itself as well, because some people really struggle with that. But just for the instance of our video, let's go ahead and continue. So what I did is I created a food choices, and I want you to tell me what type of data structure is this? What type of data structure is this? We have food choices and we have square brackets. What type of data structure is that? It's a list, right? Okay, so let's say that we wanted to go ahead and consider what we wanted to eat tonight. Our choices is paella, California rolls, Euro, barbecue pizza, double cheeseburger. Delicious, right? We have some good options. And we want to give the user the opportunity to decide what they want. So we'll say user choice equals input. Remember, input. And then what food would you like, okay? So what that would do is it would allow us to select a food. And remember, when it comes to strings, things have to be literal or they have to match. That's case sensitivity as well. So if you're going to do something of this nature, you need to make sure that you type it exactly how it's presented or it won't be able to find it. Now, there are some ways for you to circumvent that, but we won't go into that in this video. Okay, so let's give an example of a for loop within our food choices. And this might be something that happens like when you're ordering through DoorDash or Grubhub or any type of mobile ordering. You're putting in an input and it's iterating over a list, searching for what you're asking for, okay? So let's do it. Our for loop, our syntax is for, you got to start it with that, and then you got to put in and right here, this is just a variable name, right? It's a temporary variable. So we'll say for choice and food choices. I want to go back to that. So let me put in past. So what I want to do is emphasize right here, choice, that is a temporary variable. So whenever you are doing a for loop, you are defining a variable. You're defining a temporary variable. It's important for you to not use the same temporary variable name as a name that's already been indicated up there because you might override something, okay? So I decided to call it choice because that just makes sense. We're looking for choices within our food choices. So I said for choice and food choices, okay? So what that's going to do is it's going to iterate over our list. It's going to start at the first index and it's going to say, okay, this is now equal to choice. This is now equal to choice. This right here, California roll is now equal to choice. Euro is now equal to choice. Barbecue pizza is now equal to choice. Double cheeseburger is now equal to choice. That's what it's going to do. It's going to grab each iteration until you have executed what you're looking for. So what I'm going to say is for choice and food choices, if choice is equal to user choice, print, you have this item is on our list. You have selected color breakers, and we want to say choice. We'll just throw choice in there. Okay. Let's end that. So basically what's happening here is, once again, it's iterating over each food choice. It's going to look for whatever your input was, because that's user choice. And if if the choice matches your user choice, it's going to print that. So let's go ahead and execute that. So, okay, it says, what food would you like? I want some California rolls. Okay. And then it says, this item is on our list. You have selected California rolls. Well, let's say I wanted something that's not on our list. Let's say that I wanted some nachos. I love nachos. What food would you like? Nachos. It prints nachos, but it doesn't print this is on our list. Because remember, for your if conditionals, if that if conditional is not true, then it does not execute this portion right here. Okay, so let's assume that we want to get some California rolls, right? And obviously with the California rolls, it comes with a number of rows. Let's define how many rows that it comes with. California rolls equals to 12, okay? So what we want to do now is we want to demonstrate us eating California rolls, and we're going to demonstrate that through a while loop. So the way that a while loop works is you say while, and then you have your conditionals, or your conditional, California rolls greater than 0. So once again, this is your conditional right here. I think it is pretty helpful to put in a parentheses just so you know that what this program is doing is evaluating this and returning a Boolean. What's a Boolean? True or false. It's returning true or false. And it's saying, while this is true, then execute this. Okay? So what we want to do is we want to say that while that's true, California rolls is equal to minus equal 1. Okay? And what that does is, and that's an operator that's really strong and beautiful, and I haven't really talked about it much yet, but the minus equal means that it's going to subtract from this number, and then it's going to make it the new total. So each time that this happens, California rolls is going to get 1 taken away, and vice versa. If I said plus equals, then what it would do is it would add 1 to your California rolls. But the point here is, if you did it plus equal 1, this conditional will always be true, which means you'll get an infinite loop. An infinite loop is something you're going to run into often as you're learning, but it's just important to evaluate your conditions. Okay, so let's go back to minus equal 1. So while California rolls is greater than 0, we're eating a California roll. Eat California roll. And then let's print how many we have left. Print elf, you have California rolls left. Okay, so what you will see is it's going to go down from 12 all the way down to 0, right? And let's go ahead and demonstrate that. So I want California rolls. And there you are, right? That's beautiful. That's beautiful. That right there is a DoorDash. It's a very crude and simplistic way of looking at it, but that right there is a mobile order, and that's you eating it right there. So we have, what food would you like? California rolls. Okay, this item is on our list. You have selected California rolls. Then you eat one, you have 11 rolls left. You eat one, you have 10 rolls left, all the way until you have 0 rolls left. And then it stopped executing. That's what a while loop does. It says, while this condition is true. While this condition is true, then do this. The important thing here is to make sure within this that you have something that will make your condition end up being false, okay? And in this instance, we're taking 1 away from California roll. So it's just bringing it down until some point where California roll is no longer greater than 0. That's important. That's important right there, okay? So I think I'm going to cut the video right there. I have given you the tools to get started with Python, and just I want you to get in there, and I really want you to play with it. This is the basic syntax. This is the basic syntax, and the purpose of this was to get you introduced to Python, to show you that it's really simple. It's really simple. You can go from knowing zero programming or having zero coding experience to writing in Python on the first day. Within the first hour. I mean, this video was an hour, and now you're already writing Python code. That's how beautiful Python is. Okay, so for those who like Python, or if you're still curious about it, I left an exercise in the description. What I want you to do is I want you to do that. The only way that you're going to learn with Python or any type of programming language is to actually code. You can't just follow along with tutorials. You have to actually code. You have to actually make mistakes. You have to sit there and wonder why your mistakes are occurring, and you have to fix them. So I have placed an exercise in the description. I want you to go ahead and complete that. Okay, if you have any difficulties or any struggles, or if you find any problems in this video or in the exercise, please leave a comment below, and I will do my best to fix it next time. All right, so that's it. That was getting started with Python. That was your introduction to Python. I'm Lando, and I'm signing out. Deuces. No. She's gonna do it anyway. Here's Peach. I had to wait. I had to wait. She wanted to be the star of the video. Here. She wanted to be the star of the video. She's like, you're not giving me enough attention, so here it is. She wanted some attention. Say hi to the camera, Peach. All right, get off of here. She sat there for like 5 minutes. You could just tell when a cat is about to jump onto something. She just stared. I could just see it, like, she's just sitting there, like, you could just calculations. That's what she was doing, calculations. I knew regardless she was gonna jump on here. I just had to let it happen.